Welcome back. We'll look at another problem here. We will try to construct a binary tree given pre-order and in-order traversals. In the previous video, from the binary tree, we have constructed or we have deduced pre-order, in-order and post-order traversals. Here, pre-order and in-order are given. We will try to construct a binary tree. So, how do we do that? Right? So, we know that in pre-order, one is the root, right? Pre-order starts from the root, right? Pre-order starts from the root, therefore, one is the root. In order, we do not know the root here. We do not, only if we take only in order, we do not know the root. Why? Because root is somewhere in between 8 and 7. But in pre-order, we know the root. Root is 1. Right? So this is the pre-order and in-order traversal of a particular binary tree. Right? This is the in-order of this pre-order and this is the pre-order of this in-order. Right? So here, let us take 1 here. Let us take 1. So we need to find out where 1 is inside in-order. So 1 is basically here inside in-order. Therefore, we know what is in-order. In-order means left, root and right. So here I will write down pre-order means root, left and right. In order means left, root and right. Right? In order. Pre-order means root, left and right. In order, left, root and right. Therefore, in pre-order we know that the first element is the root. So we check that element inside in order. So here as we can see, root is 1. So from here we can reduce that this whole thing is nothing but the left subtree, and from 6 to 7 we have the right subtree. So can we draw like this? I think we can draw like this, right? So here I will draw like this. I will say 8, 4, 2, 9, 5, 10, 6, 3, 11 and 7. Right? Now let us check for 2. We will check for 2. Here we find 2 here. We find 2 here. Right? We find 2 here. Therefore, 2 is the root. 2 is the root and this is the left subtree and this is the right subtree for this. Right? 9, 5 and 10. 9, 5 and 10. Now let us check for 4, right? Let us check for 4. 4 is basically here. Therefore, I will write 4 here and then 8 is to the left of 4. Therefore, I will just write 8 to the left of 4. Now comes 8. Let us check where 8 is. 8 is already here. Therefore, 8 is not the root. 8 is already here. Now let us check for an element after 8, that is 5. So we are traversing from here left to right. We are checking each and every element. Let us check for 5. 5 is here. So 5 is the root and 9 is to the left and 10 is to the right, and there is only one element. Therefore, I will just write 9 and 10. If there is only one element, just write down that element to the left or to the right. So here 9 to the left and 10 to the right. If there are more than one elements, just write down those elements completely. Right? So we have finished the left subtree. Now after 5, we'll check 9. 9 is already there here. After 9, we'll check 10. 10 is already there here. Now we'll check 3. Now 3 is here. Therefore, I will just write down 3, which is the root. Now there is only one element to the left. So I will write down 6 here, and there are 2 elements to the right. So I will write down those elements as it is. Right? So we have checked 3. Now we will check 6. 6 is already there here. Now we will check 7. So 7 I will write down here. Right? And 11 is to the left of 7. Therefore, I will write down 11 here. So this is actually a binary tree from pre-order and in-order traversal. So we have constructed a binary tree from pre-order and in-order traversals. Correct? Okay. Now let us look at another example. Construction of a binary tree given post-order and in-order traversals. So I will just write this: post-order and in-order traversals. Post-order and in-order traversals. Right? This is nothing but post-order. post order and in order traversal. So given post order and in order, we will construct a binary tree, right? So what is post order? Post order means the root is to the right, complete right. So here I will just write here, post order is nothing but left, right and root, right? And in order is left, root and right. So now let us look here. Post order, we know that post order root is to the complete right. So this is the root. So in order we need to check where one is. So one is here, right? One is here. Therefore this is the left subtree, this is the right subtree, and one is the root. One is the root. Therefore I will write the left subtree as it is: 8, 4, 2, 9, 5 and 10. Right subtree 6, 3, 11 and 7. Right now we constructed a binary tree in the previous example from pre-order and in order. In that we traverse from left to right. So in post order we will traverse from right to left. So next element is 3. Next element is 3. Therefore 3 is here. Just write down 3. And the left of 3 is 6. I will write down 6 as it is because there is only one element. But after 3, to the right of 3, there are 2 elements. Therefore I will just write down 11 and 7. I'll just write down 11 and 7. So next element after 3 is 7. We are traversing from right to left. Next element is 7. So 7 is the root, right? And then 11 comes to the left of 7. So I will write down 11 here. 11 here, right? So now after 7, we look at 11. 11 is already done. Then now we will look at 6, right? 6. So 6 is already done here, right? 6 is already done. Now we will look at 2. Right? Where is 2? 2 is here. So 2 will become the root, and then I will write down these elements as it is: 8 and 4 here, and then here I will write down 9, 5 and 10. For the lack of space I am just writing a little smaller here: 9, 5 and 10. Right? 9, 5 and 10. Now 2 is done, then comes 5. Then comes 5. 5 is here. 5 will become the root. And then 9 is to the left and 10 is to the right here, right? So 9 is to the left, only one element, so I'll write down as it is, and 10 is to the right. 10 is to the right. So I'll just delete this and I'll say here 9, 5, 10. So here 5 is the root here, 5 is the root. Once we have 5 as the root, 9 is to the left and 10 is to the right, and we have written as it is, right? So we have seen just 5. Now let us look at 10. 10 is already there here. Let us look at 9. 9 is already there here, right? Then let us look at 4. Now 4 becomes the root. 4 becomes the root. This is the root, and 8 comes to the left of 4. Therefore I will write 8 here like this. So this is the binary tree from post order and in order traversal. So we have seen two things. We have constructed binary tree from in order and pre-order. We have constructed a binary tree from in order and post order, right? I hope you have understood this lecture. If you have any doubts, I would like you to comment in the comment section. Thank you for watching.